So forgot to start the record. All right, so everyone, if you could share your answers to me in the chat, or you can do an annotation on the screen. Okay, got 2 answers so far. Everyone else? Okay, don't worry if you guys didn't get the solution. So we're gonna go take a look at how we can solve this problem. So Bella or Xiang, do you guys want to share your solutions for how you guys got your answers? Oh, Leaving, good job. That's the correct answer. If any of you guys want to share your solutions.
I just added them all up from left to right.
Cool, that works. All right, anyone else? All right. All right, so we'll go through this problem. Remember, adding everything from left to right always works, right? But in AMC, we really want to conserve time on the earlier problems. So for this kind of problem, there's a trick here. We're going up by increments each time, right? So what we can actually do is find a pattern here and then group up these numbers. 90 and 99, we can group them together, right? And we'll find that if we go to 91 down here, but we subtract 1 and go down to 898. On the bottom, we group these two again, we'll see that they're the same, right? 90 plus 99 is the same as 91 plus 98. Does everyone see that? So each of these groups will be 189, right? And then here, since we have an even number, here we have even number of numbers that we're adding up. We have 10. We can just multiply 189 by 5, since that's how many groups we'll have, right? We group all of these up. And by doing that, we saved ourselves a lot of steps. You don't have to go through and add everything up. We just added 2 numbers and then multiplied it by 5. Multiply this out. 45. 9. Huh? My bad. All right, and we have 945 for our answer, which is going to be B.
Yeah, don't let this type of problem scare you, because it's basically the same idea as efficiently adding from 1 to 10, for example. Like it's all the same idea. Like they're going to scare you with big numbers, but at the end of the day, it's just crossing over. This goes to 9, and this goes to 9, and yada yada, they all go to 9. And how many lines do you have? 1, 2, 3, 4. 4 times 9, 36, right?
Really. Okay, so are we all good with that solution? You guys can let me know in the chat. And again, we're just doing this so we can save time here because these are the first few problems of the AMC. We all want to be as fast as possible. All right, cool. Looks like we're doing good. So we're going to move on to problem 3. And again, as always with AMC problems, when they ask you to do calculations, don't think about doing the whole calculation. Think of what simplifications you can make to the original problem first to solve it more quickly. All right, so we'll take around 2 minutes. So we'll come back around 7:19. So work on problem 3. All right, so it's been around 2 minutes. If you guys could share your answers with me in the chat. So far, I've gotten 2 answers. Oh. Alrighty, so the correct answer to this problem was D, 200. Azion, not quite, and we're gonna go take a look at how we can do that. Get to this answer. All right, so first of all, again, we don't want to solve this whole problem just by expanding everything out. Let's say hello.
这没法竖屏咯。
Okay, sorry about that. All right, let's keep going. So first of all, taking a look at this problem, has exponents on the top and the bottom, right? So with powers of 10 here, it's just going to be that many zeros. So 10 to the 7th will be 1 with 7 zeros. And when we're dividing the top and the bottom, we can actually just cancel these out, right? So for example, if we had 100 divided by 10, what are we doing? We're just getting rid of the 0, right? Because we're dividing by 10. And it's the same thing with powers of 10. So if we had 10 to the 7th divided by 10 to the 4th, we would just get 10 to the 3rd. So right away there, we can make a quick, big simplification of the problem, and we can end up with 10 to the 3rd divided by 5. And 10 to the 3rd gives us 1,000. 1,000 divided by 5 will give us 200, and that is our answer.
Yeah, so for those of y'all who aren't familiar with exponents, when you have two numbers, for example, a to the 2nd and a to the 3rd, if you want to multiply them, you basically end up with, by adding the exponents together, you get a to the 5. And if you want to divide them, if you want to divide them like that, you basically have to subtract the first one with the second one. So you get 2 minus 3 on the exponents, and you get -1. And just as an extension out there, I don't know if this is in the curriculum, but if you have a negative exponent, the number goes under. Like, for example, a can be any number, like 3 to the 2nd times 3 to the 3rd, and then it ends up like 3 to the 5th. You can do the same thing for division. It'll just end up being 3 to the 2nd and 3 to the 2nd divided by 3 to the 3rd, which is 3 to the power of 2 minus 3, which is 3 to the -1. So we squiggle that out. It's 3 to the -1. And negative exponents, you basically just put the number underneath 1, like as a numerator. It's basically a fraction, and you keep the number here. Like it might be a little bit too complicated, I'm sorry, but just let me know if you have questions. Yeah.
All right, so the takeaway for this problem was when we get big exponents here for division, you can just take steps to simplify the problem again. Same concept as the other two, just trying to make the problem easier on ourselves so we can solve it more quickly. All right, so do you all get the gist of this one? You let me know in the chat or give me a thumbs up. All right, cool, Serena's got it, everyone else? Again, if there's anything you guys are confused about or you need another explanation, just let me know. We can always go back to things. Angela's got it. All right, so we're going to move on to the next problem. Problem 4. We'll take, again, around 2 minutes to solve this one. All right, you guys need a little bit more time, or are we all good on this problem? All right, Serena's finished. Dion's finished. Everyone else? Just give me a thumbs up if we're all good on this problem. We can start working on the solution. All right, so let's take a look at this problem. We're looking for the area of polygon ABCDEF in square units. So when we see these problems looking for area and the shape here is not really normal, we can just split it up into simpler shapes that we already know how to solve the areas for, right? So in this case here, we can split it up into two shapes like this. We can have square in the bottom and a little rectangle on top, or we can choose to split it this way. Either way is fine. And we'll just go with the square on the bottom for now. Right, and by splitting this up, we need to find some new side lengths for these shapes. So for the top one here, we draw this out. For the top rectangle, we already know the side lengths, right? We can already have 5 and 6 here, so we can find that the area is 30. And the bottom, to find this side length here, we would just take this side length on the right, which is 9, and subtract 5. If the whole side is length 9 and this is length 5, then this is length 4. We have a square on the bottom, we solve for the area 16, and then we add these two areas up to get 46 as our answer. All right, so that was a pretty quick problem. Do we have any questions in the chat? If you guys could give me a thumbs up if we're all good, or if you have anything you don't understand, just let me know.
So I want to add something here. If you see like geometric problems in AMC, definitely always consider adding supporting lines. Like don't be afraid to add them. They most of the time all they only do is help. I've taken math classes in China, and that's basically the gist of everything there as well. So you gotta love your supporting lines.
All right, so that's it for this problem. Hopefully that wasn't too hard, and we'll move on. Okay, so this one is a little bit more reading for this problem. We'll go read through it together. The bar graph below shows the grades in a mathematics class for the last grading period. If A, B, C, and D are satisfactory grades, what fraction of the grades shown in the graph are satisfactory? All right, so let's take around 3 minutes for this problem. Okay, so I've gotten a few answers in the chat. For the rest of you guys, do we need a little bit more time or are we good to go on to the answer? All right, looks like we're good. So a lot of people got the correct answer in this one, and this problem might look intimidating, but let's break it down and we'll see that it's actually not too difficult. All right, so first of all, this bar graph here is just displaying the grades for people. Oh, Angela, yeah, good job, it's the correct answer. All right, so the bar graph here is just displaying the grades and asking for what fraction of the grades in the graphs are satisfactory. And we know that A, B, C, and D are satisfactory. So when it's asking for a fraction, we're just asking for how much we're looking for, right? Versus the total. So the total in this graph is just going to be all of these numbers added up, right? So we have 5 for A, plus 4, plus 3, plus 3, plus 5, which gives us 20. So our total in this is 20. And now we're just looking for all of the grades that are satisfactory. And again, we already know that. That's A, B, C, and D, which is going to be 5 plus 4 plus 3 plus 3, which will be 15. And we can just simplify that fraction to give us 3/4. All right, so this problem was a little bit more reading, but again, if you ever are not sure what the question is asking, just go back, look through it again. You'll see that often it's not as complicated as it seems. In this case, we're just looking for a fraction. Oh, sorry. All right, so do you all get that? If you have any questions, let me know in the chat or unmute. All right, okay, looks like we're doing good. So we're gonna move on to the next one. Problem 6. So this one, a stack of paper containing 500 sheets is 5 centimeters thick. Approximately how many sheets of this type of paper would there be in a stack 7.5 centimeters high? So we're looking for how many sheets for a stack 7.5 centimeters high. All right, we'll take around 2 minutes to work on this problem. Okay, so it's been around 2 minutes. So do you guys need some more time or we all tried this problem already? Okay, so I got 3 answers in the chat. They're all correct. So Zion got it really fast. Do you want to talk about how you got to your answer? If you want.
Well, basically, if you figure out that 100 sheets is just 1 centimeter thick, so if you were to times 100 by 7.5, that would be 750.
Yep, great job. Yeah, and Serena, your solution is correct as well. So yeah, this problem, you can solve it using ratios, right? You can write it 500 to 5 and then write it 100 to 1 and then multiply that. But when we're just looking at this problem, you see really quickly 500 sheets is 5 centimeters. So 100 sheets is 1 centimeter, multiply by 7.5. And we'll see that we can get 750. Alrighty, so do you all understand this problem? So sometimes we'll need to use ratios and do a little bit more calculations, but for problems like these, read through it first. If you don't need to write down a bunch of numbers, you don't have to. And get through it more quickly. All right, so we move on to the next one. This is going to be a pattern problem. So let's read it real quick. A stair-step figure is made of alternating black and white squares in each row. Rows 1 through 4 are shown. All rows begin and end with a white square. And we're looking for the number of black squares in the 37th row. So each row is like this. You have row 1, 2, 3, and 4. We're going to look for the number of black squares in the 37th row. All right, so let's take, again, 2 minutes. This problem, see who gets the answers.
I think it's about time. Yeah. All right. Jonathan, you ready?
All right, cool. So let's take a look at this problem. So I got a few answers in the chat. Bella, you're correct. Xiang, almost. Very close. Li Ming also got the correct answers. So let's take a look at this. This problem is a question problem. This is a puzzle problem, right? So we're going to take a look and see that we can find some patterns in what we have already. So we're looking for the number of black squares in the 37th row. And obviously we're not going to draw out all 37 rows and count them, right? So let's take a look what we have here. In the first row, we have 1 white square and we have no black squares. In the second row, we have 2 white squares and 1 black square, right? Third row, we have 3 white squares, 2 black squares. And in the fourth row, we have 4 white squares and 3 black squares. So from this, we can sort of find a pattern, right? So for row n, we will have n white squares. We also have n minus 1 black squares. In other words, the number of black squares in a row will always be one less than the number of white squares. So we're looking for the 37th row. That means there'll be 37 white squares and there'll be 36 black squares.
I feel like for AMC, the tactic to dealing with these pattern questions where they want like you to find a specific value at like a really large row number iteration, your objective is to never draw out the graph unless you have a lot of time and you really don't know what else to do. But what you should do is basically don't be scared by the large numbers and just try to list out all the facts and try to find a simple correlation between them. Here you would correlate the row number to how many, what the heck, sorry. You correlate the row number to how many black squares you have. Yeah.
And again, we're only at problem 7 here, right? So usually before problem 15, if it's asking you to count a big number, there's always going to be some sort of fast trick to get you to the answer. Problems before from 1 to 15, you usually don't want to spend too much time on, and especially problems 1 to 10, at most 1 minute each. So there will always be some quick trick to get you to the solution. Alrighty, do we all understand that one? We had few little counting mistakes for our answers, but hopefully you all figured that one out. All right, Serena's got it. Everyone else, we're all doing okay? Can you give me a thumbs up in the chat or? All right, cool. So we're gonna move on to problem 8. Okay, so for this one, we define A as -2, and we're going to be looking for the largest number in the set, -3a, 4a, 24 divided by a squared, and 1. All right, so we'll take around 2 minutes for this one. And let's see how we do. All right, so I've gotten a few answers already in the chat. So do we need more time on this problem, or you guys haven't got to the solution? No response. All right, so I guess we'll just take a look at the solution. So for this problem, the quickest way is just to really look through and evaluate things, right? We can just go through, plug in -2 to all of these, but a little faster way is to look at the positive and negative signs, right? We can first see that A is -2, and we're looking for the largest number. So ideally it'd be something positive, right? So you look negative times negative will give us something positive. right away, we're not going to use 4a, right? Because we have a positive number times a negative number. We're going to get a negative number here. Same thing with 24 divided by a squared we will have to consider, right? Negative 2 squared is going to be 4. And then 1 is already less. So now we just have to compare 6 and 4. That'll obviously be 6 because negative 3 times negative 2. You can use positive and negative to eliminate some of these, such as these two. But honestly, just plugging in negative 2 to all of them pretty fast as well. And again, when we're asking for largest number, in case we need a quick review on this, we're going to be looking for 6 instead of negative 8, right? Because 6 is positive here. We're looking for the greater value. Negative 8 is going to be negative. So obviously, we're going to pick 6. Alrighty, do we have any questions on that? Any questions? Unmute, let me know in the chat. And again, for everyone, you can just send me direct messages if you want, or you can just send it to everyone. Okay, Serena gives a thumbs up. Everyone else, we're all doing okay? All right, so we're going to move on to the next problem. Okay, so problem 9, we'll be looking for the product of these 9 factors. Again, this is a pattern that's continuing up, right? We have 1/2, 1/3, 1/4. Next one will be 1/5, 1/6, and we're going to go to 1/10. So we're going to take around 2 minutes to do that. And again, if you guys are ever stuck on these problems, you can just, if we're still working on the problem, just let me know in the chat what part you're stuck on. That way you can give an explanation of that. All right, so I haven't gotten any answers yet. Do you guys need some more time? Or are we stuck on this problem? In response, if you guys could let me know if you need some more time to work on this, or if we're all stuck, you'll just go through the explanation. All right, no response. All right, we'll just go through and explain this problem. So first of all, I hope we can all see the pattern that's going on here, right? So just for explanation, I'll write out the full thing. And in a test, you wouldn't really write out the whole pattern unless for some problems when you absolutely have to. And so on. I don't have enough space here, but hopefully we can see that's what the problem, what the pattern is. And we're looking for the product of all these. So first of all, we would evaluate what's inside the parentheses, right? So going down the line, give us 1/2, 2/3 times 3/4 times 4/5, and so on. And we're going to go all the way until we reach 9/10. So do we see a pattern here? Could you guys let me know in the chat or unmute, see if you guys can see the pattern that's popping up here? All right. Yeah, Serena says the second numerator is the first denominator. So yeah, so as you can see, the bottom 1/2 is going to be the top of 2/3, right? We have 2 and 2, 3 and 3, 4 and 4. I'll switch to a different color here. We can see these groups. Oh, sorry about the bad circles, but hopefully we can see that these are all numbers that we can cross cancel. Right? So we don't have to go through and multiply everything. We just cross cancel these numbers out. 2, 3, 4, and so on. And we can see that this will keep going until we hit 9, right? 9 will get cross-canceled with 8/9, and the 8 will get cross-canceled with the other ones. So what we're left with is only the numbers 1 and 10. So that'll be our answer. Our answer is going to be 1/10. So this time we did have to do a little bit more work, right? We had to evaluate what was inside the parentheses, but once we figured out a pattern for that, we can look for quick, easy solution. In this case, everything canceled out pretty nicely. And if you were stuck on this problem while you were doing the actual test, I would recommend just skipping it for now. Don't spend more than, let's say, like around 20 seconds thinking about it. If you can't find a solution immediately for numbers 1 through 10, just skip over it and make sure you come back later on in the test. Okay, if we're skipping over problems in 1 through 10, you've got to make sure to find some time to come back to them, because these are usually problems that are a lot easier than what's going to be later on, and each problem is worth the same amount of points. So do we all understand the solution for this one? Again, just finding a pattern and then canceling out. Can we get a thumbs up if you guys understand? For any questions left, please let me know. We can go ahead and go over them. One thumbs up. All right, Serena, Angela, Li Ming, you guys all got it. So hopefully everyone else has got this too. We're going to move on. Okay, problem 10. We're going to be looking for the fraction that is halfway between 1/5 and 1/3 on the number line. So again, we'll take around 2 minutes to do this one. And for people that haven't been sending any answers, if you have any answers that you get or any problems you encounter while solving this, just let me know. And Serena, it's not quite A. We'll be looking for the point right here where I marked with the green line. All right, so it's been around 2 minutes. I had some good answers in the chat. And now let's go over the explanation. So for everyone that didn't send an answer, again, if you have an answer that you think is correct, just send it to me. You don't have to send it to everyone. You can direct message. And if you have any questions that you encounter during the problem, let me know as well. All right, so we're going to be looking for the fraction that's halfway between 1/5 and 1/3. And it's easy to think that it might just be 1/4 since 4 is between 5 and 3, but that's not quite. The answer is there sort of as a little trick to get you. So the easiest way to solve this one, we're looking for some point halfway between, right? So we would look for a common denominator. In this case, for 5 and 3, that would be 15. Since these are both prime numbers, we would just multiply them to get 15. So 1/5 would become 3/15. 1/3 would become 5/15. And once we've written that out, it's a lot easier to see where the answer is, right? 3/15 here, 5/15 here. So the one in between would be 4/15. That would be C. All right, so do we all understand that? Don't worry too much if you fell for the 1/4 here. AMC will often put some really quick, easy answer there that might seem correct at first, but most of the time, if it's not too much writing, take some time to actually figure out the correct answer before circling. All right, 758. So we don't quite have enough time for another problem, so I guess we'll wrap up for today. So I guess this is the start, not really the start. This is us getting back to AMC practice for the coming AMC test, which will be in January. But thank you, everyone. Again, if you have any questions about the problems that we went over today that you want to ask later on, please feel free to go ask them on our Discord. Let me send a link to that here. I'll put the link in the chat. And also the problems that we did today are the 1985 AJHSME problems. So if you want to look back at these problems and the official solutions, they're all on that link right there. Next week, we'll probably be starting a different set of problems. We'll be going over 1 through 10 again. And then once we've gotten the hang of those, we'll move on to some harder problems. But yeah, that's it for today. If you have any problems about any of the questions, stick around. Oh yeah, the Discord link. Thanks for reminding me, Serena. Let me get that. Hey, you guys are free to go. If you have any questions about the problems, stick around and ask me.
Thank you. Bye.
Yeah, thanks.
Bye.
Great job today. For the people that stuck around, sorry about the link. It's a little bit slow. Yeah, Serena, I'm gonna go to 11th grade next year. Let me stop the recording. Forgot about that. Okay, Serena, no problem. Great job today.